All right, there are 6 examples on the student notes for day 2 of implicit differentiation. And I'm just going to show you what I believe are the answers to those questions. And then I will come back and go through all of the questions. But if you don't need that, then you can kind of jump to the video where you need to be. So question 1 and 2 answers are here. Question 3 and 4 answers are here. And I have written them in vectored form. Question 5 and 6 answers are here. All right, I'm going to go back to example number 1 and attempt to show all the work. So it says find an equation of the tangent line to the curve x to the 2/3 plus y to the 2/3 equals 4 at the point x equals -3 square root 3 and y is 1. And just for later use, 3 times the square root of 3 is the same as 3 to the 3/2. Okay. All right, so let's start with the derivative. Implicitly differentiating, we're going to get 2/3 x to the -1/3 plus 2/3 y to the -1/3 times dy dt equals 0. Isolating the dy dt term, we will move the x term to the other side. All right, dividing by the y term, leaving dy dt, we get -2/3 x to the -1/3 over 2/3 y to the -1/3. Okay, simplifying a couple things, the coefficients of 2/3 will drop out, leaving a -1 coefficient. The x to the -1/3 and y to the -1/3 can switch locations due to the negative exponents. All right, so we really have negative cube root of y over x as our first derivative or derivative of this function. Okay, we want to evaluate this at the x and y value, -3 root 3, comma 1. Okay, so that means we're going to get a negative cube root of 1 over -3 square root 3. Okay, the cube root of a negative is a negative, so these negatives will cancel out. And we're left with 1 over 3 square root 3 to the 1/3 power. Okay, here's where I'm going to look at 3 square root 3 as 1 over 3 to the 3/2. Raising that to the 1/3 power. You multiply the exponents, so we're left with 1 over the square root of 3. That is the slope of the tangent line to this curve at the point given. There's our slope, and here's the equation in point-slope form. Okay, question number 2. If x times the quantity f of x cubed plus x times f of x is equal to 6, and f of 3 is 1, find f prime of 3. All right, so we need to use the product rule and chain rule to find the derivative. So x times 3f of x squared times f prime of x plus f of x cubed times the derivative of x, which is 1. That's just the derivative of the first term. Okay, plus the derivative of the second term, x times f prime of x plus f of x times the derivative of x, which is 1, equals 0. Okay, so we'd like to find f prime of 3, which to me says we should isolate all the terms that have f prime in them. And we should solve for f prime before moving on. So I'm going to move the terms that don't have f prime in them to the opposite side of the equation and factor the f prime from the terms that are left. So f prime of x times the quantity 3x f of x squared plus x equals negative f of x cubed minus f of x. Okay. Isolating f prime of x, we will get negative. I'm going to factor a negative away from these guys. So negative f of x cubed minus f of x. I could have factored an f of x as well, but we'll leave that for now. Divided by, I'm going to factor of x times 3 f of x squared plus 1. Okay, so we have f prime of x. We'd now like to find f prime of 3. So I'm going to need to evaluate this function when x is equal to 3. So f prime of 3 is equal to negative f of 3, which is 1, minus f of 3, which is 1. Oops, that should be a plus. I said I was going to factor out a negative. Okay. Fix that up. All right, negative quantity 1 cubed plus 1 over 3 times the quantity 3. F of 3 squared is 1 squared plus 1. All right. So if I haven't made any more mistakes, it looks like I have negative 2 in the numerator. And 3 times 3 minus 1, which is 2, in the denominator. Oh, made another mistake. That should be a plus. And so this is going to be 3 times 4 in the denominator. All right, better. Let's reduce by a factor of 2, so we're going to get negative 1 over 6. Phew, thank goodness. Gotta watch the algebra. Okay, let's see if we can get one more example in here, maybe 2. All right, example number 3, it says find the second derivative. So first we must find the first derivative. Derivative of x cubed is 3x squared. The derivative of y cubed is 3y squared times dy dx. Derivative of 1 is 0. Isolating 3y squared dy dx is equal to negative 3x squared. Reducing the factor of 3 and dividing, dy squared, or dy dx is equal to negative x squared over y squared. All right. I'm just going to move that out of the way because the second derivative requires a little bit of space here too. So the second derivative, d squared y over dx squared, will be equal to the derivative of this quotient. So I have to use the quotient rule. So that's low, y squared, times the derivative of high, negative 2x minus high, so it's plus x squared, times the derivative of low, which is 2y dy dx, divided by y to the fourth. Okay, what we're going to do is we're going to substitute dy dx in for the dy dx here. Okay, so here we go. Let's simplify a little bit. Negative 2xy plus 2x squared y times dy dx, which is negative x squared over y squared, divided by y to the fourth. All right, let's get a common denominator in the numerator. So that's a negative 2xy cubed plus 2, how about minus 2x to the fourth. That's all over y squared. And if I also divide by the y to the fourth, that's in the denominator as well. All right, my 4s are kind of looking like 9s. So let me clean that up. Okay. Just double checking my work here. I missed my factor of y. Here we go. Okay, so simplifying a little bit more, I can reduce by a factor of y. So negative 2xy squared minus 2x to the fourth over y to the fifth. Factoring out negative 2x. Did I miss something? All right, looks like I missed something. I'm going to have to check my work on this. Because I have an x cubed and a y cubed up here. So I will check that and get back to you in the next video when I finish examples 4, 5, and 6.